In Lesson 7.3, you will express numbers in scientific notation. You'll also find products and quotients of numbers that are expressed in scientific notation. Scientific notation is just a shorthand way to write very large or very small numbers. Right here we have the recipe for what a number looks like in scientific notation. It's a number times 10 to some power. This number that belongs right here has to be a number that's at least 1 but less than 10. In other words, you need to have exactly one number in front of the decimal point in the number. And then this number right here, the exponent, tells you the number of places that you move the decimal point. Because remember, when you multiply by powers of 10, you are just moving the decimal. In the first example, it says to express each number in scientific notation. So right now in this number, 201 million, the decimal point, if it's not written in the problem, it's at the end. So we're going to take that decimal and we're going to move it until we have a number that is at least 1 but less than 10. So we're going to move it between the first and second number. I like to kind of think of the decimal point as like the steering wheel, and you can only have one driver. There should be one person at the steering wheel. All the rest are passengers. So 2.01. I do not need to write these zeros here. I do need the 0 between the 2 and the 1 because it's holding a place. So 2.01 times 10 to the 8th power. Now, one thing I forgot to mention up here with scientific notation is that positive exponents are for really large numbers and negative exponents are for really small numbers, the numbers between 0 and 1. Since this is a large number, it's going to be a positive exponent of 8. Now when we move to this one, this is a little number. We're going to take the decimal point and we're going to move it between the 5 and the 1. And we don't need to write all these zeros down. We're just going to write 5 and 1/10 times 10 to the 1, 2, 3, 4, 5. It's going to be negative 5th power because I moved it 5 places, and this is a really little itty bitty number, so it's going to be to the negative 5th power. You may want to pause the video and try the next two on your own. The decimal point right now is at the end. We're going to move it up between the 6 and the 8. 6.87 times 10 to the 3, 6, 9, 10th power, and it's going to be positive because this is a large number. Now this one, we're going to take the decimal point and move it between the 7 and the 2. So 7.25 times 10, and it's going to be a negative exponent because this is a little number. We moved it 1, 2, 3, 4, 5 places, so negative 5th power. Next, we're going to go the other direction. We're going to take a number in scientific notation and write it in what's called standard form, or as a regular old number. This first example, since it's a positive exponent, that means it's going to be a big number, so we're going to want to move the decimal to the right 9 places. Or think of it this way, every time you multiply by 10, you move it 1 place to the right. So this is going to be moved over 9 places. So we're going to have a 6, a 3, a 2, and then we need to add 7 more zeros. Now when you go ahead and put in your commas, remember it's every 3 numbers from the back end. So there's your answer. One common mistake I'd like to point out is a lot of students think that this number has to do with how many zeros you add, and it does not have to do with the number of zeros. It has to do with the number of decimal places you move. I think the misunderstanding comes from when you were maybe in elementary school and you didn't have decimal numbers that you were multiplying. Maybe it was just a whole number, and then it would be the number of zeros, but because we have this decimal, two of the places aren't going to be zeros, it's going to be the 3 and the 2. Next up, we have 4 times 10 to the negative 7th. Since it's a negative exponent, this means it's going to represent a little itty-bitty number. So we're going to take the decimal point that's after the 4 and we're going to move it 7 places to the left. So that means we're going to end up having to put in 6 zeros and then the 4. So 6 zeros after the decimal and the 4. So that's a total of 1, 2, 3, 4, 5, 6, 7 places. You may want to pause the video and try the next two on your own. This first one here has a positive exponent, so it's going to represent a large number. So we're going to make this number bigger by moving it to the right. We're going to take that decimal and we're going to move it 6 places to the right, which means we're going to have to add 3 more zeros. Now this example is a negative exponent, so that's going to represent an itty-bitty number. So we're going to take the decimal and we're going to move it to the left 5. So we're going to need 4 more zeros after the decimal point, then the 903. The last thing we're going to do is multiply numbers that are written in scientific notation, and it's going to rely on some of the rules you learned earlier in this chapter. First, because of the commutative property, we're going to multiply the 3.5 times 7 first. We're going to take 3.5 times 7. 3.5 times 7 is going to be 24.5. And then now we're going to multiply the 10 to the negative third times 10 to the fifth. When you multiply powers with the same base, you need to add their exponents. So negative 3 plus 5. Negative 3 plus 5 is going to be 2. So this is going to be times 10 to the second power. Now what we want to do is write it both in scientific notation and standard form. This looks like it might be scientific notation, but it's not because this number is too large. It needs to be a number that's less than 10, but at least 1. What I find to be helpful is to first put the number in standard form. I'm going to put just SF for standard form. Standard form means I'm going to take this decimal and move it 2 to the right, since that's a positive 2. And I end up with 2,450. Now to put it into scientific notation, I want to take the decimal point that's at the end and move it between the 2 and the 4. So 2.45 times 10, and it's going to be a positive exponent because it's a large number, and I moved it 3 places, so it's a positive 3. So there's standard form and there's scientific notation. You may want to pause the video and try the next one on your own. Again, due to commutative property, we are going to multiply these two numbers together first. 6.5 times 8.7. That's going to be 56.55. And then we're going to go ahead and multiply 10 to the 12th times 10 to the negative 15. Since those both are the same base, we can add the exponents. 12 plus a negative 15 is negative 3. I guess I meant to write that we were going to add those together. When we add those together, we end up with 10 to the negative third power. Now again, that's not quite in scientific notation, so I'm going to go ahead and put it in scientific notation, standard form first. Standard form, since it's a negative exponent, I'm going to make the number smaller by moving it 3 decimal places to the left. So it's going to end up being 0.05 0.655. And now we're going to put it into scientific notation. We're going to move the decimal so we have a number that's at least 1 but less than 10. So it's going to move between the 5 and the 6. 5.655 times 10. And since this is a little number, it's going to be a negative exponent. And we moved it 2 places, so it's negative 2. Now the last thing we're going to do is we're going to divide with scientific notation. Same idea. We're going to go like this, and we're going to look at this as being 2 separate pieces. This right here times this right here. So if we start out and do this division, 3.066 divided by 7.3, that's going to equal 0.42. And then times, when we're dividing powers with the same base, we subtract the exponent. So we're going to subtract 8 minus 3. So this is going to be 10 to the 5th power, because 8 minus 3 is 5. Now, the next thing I would do is I would write it in standard form. Standard form is going to move this decimal 5 places to the right. So 42000. And then now put it in scientific notation by moving the decimal between the 4 and the 2 times 10. And I moved that 4 places, and it's a big number, so it's going to be a positive 4. You may want to pause the video and try the last one on your own. Start out by doing this division right here. That's going to be 1 and 21/100ths times this piece right here. We're going to subtract these exponents. 3 minus 8. 3 minus 8 is negative 5. So it's times 10 to the negative 5th power. Now I would go ahead and write that in, well actually it's already in scientific notation because this number right here is a number that is less than 10 but at least 1. So this right here is going to be our scientific notation. And then our standard form, since it's a negative exponent, we're going to move it 5 places to the left to make it a smaller number. So we're going to have to put 4 zeros after the decimal, and then the 121.